Okay, so guys, in this video, we are going to see what is the second derivative test. Of course, we will solve some examples relating to this topic. While doing the second derivative test, there are some specific steps which should be followed and some additional steps which are actually not necessary, but I will tell you what those steps are. Okay. So while doing the second derivative test, it's an obvious thing that we will take the derivative two times. Let's just suppose you are given a function f of x. So the very first step of this test will be taking the first derivative. And then the second step will be letting this function equal to 0. So you have to let this derivative, the first derivative, equal to 0. By doing this, you will get some values of x. These values of x are known as the critical points. Then in the fourth step, you will take the second derivative. This is the fifth step, which is actually an additional step. It is not necessary. And this step actually says that this second derivative of x should also be let equal to 0. And then you will get a value of x, which will be known as the inflection point. Now this inflection point, this value of inflection point is actually not really important. But if you learn about it, if you know these, you can get some specific information about the function. You will come to know about it in the upcoming videos. But for now, our main focus will be this critical point right over here. In the sixth step, which is actually the most important step, the value of the second derivative, you got some value of second derivative. Now you have to put this critical point into that second derivative. Okay, so you have to basically put the value of the critical point into the second derivative. Don't worry, just don't get intimidated about it. We will solve some examples related to it, and then you will come to know what is this thing. Now, based on the results calculated from the sixth step, you will get some important things which will be your result of the second derivative test. The result will be either a graph will be concave up or it will be concave down. If the graph is opening up, its mouth is opening upwards, then it will be called as a concave up graph. Now remember this thing, whenever you see a concave up graph, that graph is going to give you the value of minima. This is a very important thing because the graph is opening up and you are getting the least possible value for the function, okay, the minimum. And then if the graph is concave down, which means that its mouth is opening downward, at that point you will get the value of maxima, the highest possible value the function can attain. Okay, so this is the second derivative test is also known as the concavity test. Why? Because it tells you that either the graph is opening concave up or down, and by knowing that specific concavity, you can find the values of minima and maxima for a function given to us. Now, one more important thing. If the second derivative test is greater than 0 at, of course, the value of critical point, the function has a minima, right? If the second derivative test at the critical point is lesser than 0, then the function has a maximum. The graph is concave down. The value for the second derivative test will be negative. And for the minima case, for the concave up case, the value will be positive. But if the second derivative test at the critical point is equal to 0, then the test is inconclusive. i.e., you cannot draw any conclusions from it. You will not get the value of minima or the maxima from that graph. Okay, let's try some examples. Okay, so the first function which we have is 2x cubed minus 12x squared. So the first step is taking this first derivative, then letting it equal to 0. Then the third step is taking the third derivative. So let's do these things. First of all, the first derivative. So 2 will be separated because it is a constant. The derivative of x cubed will be 3x squared minus 12 will be a constant. It will be separated. Derivative of x squared will be 2x. Now let's simplify these things. 2 3s are 6, x squared minus 12 2s are 24, x. This is the first derivative. Now we have to find the value of the critical points by letting this function equal to 0. So the second step, 0 is equal to 6x squared minus 24x. Let's add 24x on both sides. So we will have, these will be cancelled. We will be left with 6x squared is equal to 24x. Now this x can be cancelled by the first power over here, and we will get 6x is equal to 24. Now the value of x will be 24 divided by 6, and x will be equal to 4. This is the critical point. Now another obvious value of x is 0. This is an obvious value of x. Why? Let me tell you. If we just simplify this function as 0 is equal to 6x squared minus 24x, we can see that the x is actually common, right? So x can be taken out as common. We will have 6x minus 24. Now, the value of x will be 0 and the value of this thing, 6x minus 24, will be equal to 0. So we see we have two values of x. And this is actually very important because the critical point always need to have two values. Okay? So 6x would be equal to 24, and again we will get the value of x as 4. So now we see that it is necessary to get two values, two critical points. Why am I telling this? Because at the end you have to put these critical points into the second derivative, right? And after putting it into the second derivative, you will get the relative minima and the maxima. If you are only getting 4, which means that f is greater than 0, the second derivative of x will be greater than 0, you will get a positive value, the graph will be concave up, you will only get the value of minima. How will you get the value of maxima? By putting it into the second phase. Okay, so now let's take the second derivative of this function right over here. So the second derivative, the third step of second derivative test, so d by dx, 6x squared. So the derivative of 6x squared will be 6 2s are 12x minus the derivative 24x will be just 24. Let's put the value of these critical points into this function right over here. Okay, so first of all, x is equal to 0 and also x is equal to 4. 12x minus 24, 12 times 0 minus 24. This will actually be equal to 0. We will get negative 24. And 12 times 4 minus 24. 12 times 4 is 48 minus 24, which will be equal to 24. We can see this value is positive and this value is negative. At this point, the graph will be opening upwards. Its mouth will be opening upwards. So we will have the concave up condition. And if we have the concave up, we can calculate the minima. What is the minima? This thing, x is equal to 4, is my minima. And if the graph has a negative value of second derivative, it will be opening downwards. And if it is opening downwards, we will get the maxima, right? The value of my maxima for our condition will be 0. Okay? So this is how we can calculate the relative minima or the maxima using the second derivative test. So for our condition, the relative minima is 4 and the relative maxima is 0. Okay? Now let's try one more example. Okay, so there is a function 4x cubed minus 6x squared minus 24x plus 1. Now I would like you to try this question on your own and then watch my solution. So let's take the first derivative as a first step of solving this question. Now the derivative of 4x cubed will be 4 3s are 12x squared minus derivative of 6x squared will be 12x. Derivative of 24x will be negative 24 plus 0. Now let's find the critical points. So 0 is equal to 12x squared minus 12x minus 24. Remember, in any case, I have to determine two values of this critical point. So of course it is a quadratic equation and we can simply solve for the quadratic equation. So let's just use the quadratic formula. So a is equal to 12, b is equal to negative 12 and c is equal to negative 24. You can use the factorization if you know the factors, but yeah, I'm feeling comfortable with the quadratic formula, so I'm going to use that. So the the critical points are x is equal to 2 and x is equal to negative 1. Now let's take the second derivative, the third step actually. So the second derivative of this thing right over here. So d by dx. So this will of course be 0. And the derivative of 12x here will be 24x minus the derivative of 12x will be 12. Now let's put these critical points into this second derivative. So we have two values, x is equal to 2 and x is equal to negative 1. So 24 times 2 minus 12 and 24 times negative 1 minus 12. 24 times 2 is 48 minus 12, it will be negative 24 negative 12. 48 minus 12 is positive 36 and negative 24 minus 12 is negative 36. So you can see this point is actually lesser than 0, right? And this point is greater than 0. So the second derivative at the critical point is greater than 0 over here. And over here, the second derivative at the critical point is lesser than 0, right? If the second derivative test is lesser than 0, the graph will be concave down. And if the second derivative test is greater than 0, the graph will be concave up. So at this point, when the graph is concave up, you will get the minima. What is the minima? X is equal to 2. And at this point, when the graph is concave down, you will get the maxima, the maximum value that the function can achieve. And that is -1. Okay, so I hope you get the point. And in upcoming videos, we will solve some more example related to this test.